the third session in the monsoon crash course. And guys, today we are having a wonderful topic which is very important for both mechanical and civil branch. And guys, today's topic is related to the principal stresses and strain. So please tell me, am I properly audible and visible to all of you or not? Yes. Then we are starting the session, guys. And also, as you know, some of the questions were pending from simple stresses and strain and also from the bending and torsion. So I have taken those questions in today's session. Okay, so we will also solve those questions and then we will be having the questions from principal stresses and strain. Is it fine, guys? So do like and share the session so that others people can also reach here and we can go with the sessions. Yes, guys. Yes, Piyush ji, good evening. Midun, good evening, dear. What about others? Yes. We are starting the session. Madhuvamshi, hello. Yes, good evening, dear. So guys, we are starting the session now. So as you know, this is the topic which is nothing but, I will say, the heart of the SOM, because all the times the questions are coming from this topic, as Mohr circle is also coming in this topic. Kenil, good evening, dear. Yes, I welcome you all in this session. Those who are watching me for the first time, guys, this is some introduction about me. I'm having 10+ years of experience in this field, cracked GATE many times with good ranks, written many research and review papers, and the subject going on is strength of material. These are the other areas of interest. Nikhil Rana, good evening, dear. So guys, we are starting the session and this is an information like right now the GATE Rankers Monsoon crash course is going on. This is a free for all, and guys, in this we are covering almost 6 to 7 subjects. Okay, and those 6 to 7 subjects are having the weightage more than 70%. Okay, so those all the subjects we are going through, and the way of teaching is learned through questions. And guys, this is for all the students who are preparing for GATE. Sachin Gautam, good evening, dear. Yes, Sam, good evening, dear. So this is an information related to the workshop which would be taken by Abhinav Negi sir on 3rd of July at 12:30 p.m. So those who want to attend this workshop, this is also for free. And for this is going to be complete roadmap for GATE preparation. This is the topic of workshop, and for that you can register, guys, for free once again. So let us start the session. This is the very first question in front of you, guys, and the very first question I have taken from principal stresses and strain. Then in between we have the question from simple stress and strain, taper bar, bending, torsion, all the types are covered. Imon Kalita, good evening, dear. So this is the first question, guys. In a plane strain problem in XY plane, the shear strain is this much. Normal strain in X and Y direction are 0. For this state of strain, what is the diameter of the Mohr circle of strain? They are asking about the dia of Mohr circle. Yes, for the strain, not for the stresses. Yes, Jishnu, can you tell me, are you from mechanical or civil? Actually, we have already shown the complete timetable for that in the generic session of golden rules. So can you tell me, are you from mechanical or civil? Okay, Bhavya have given the answer. So if you are from mechanical, my dear, the subjects are strength of material, fluid mechanics, and then you are also having industrial engineering, production technology, theory of machine, thermal sciences. So except engineering mechanics and machine design, we are covering all the subjects. Okay. If you are from civil, geotech is there, RCC is there, SOM is there, FM is there, OCF is there. Okay. So all these subjects are going to be covered. Environment is there. Okay, Jishnu, then I have already given you all the subjects names. Vamshi, okay. So all are saying the answer to be C. Yes, yes, yes. Madhuvamshi is saying the answer to be C. Piyush ji is saying the answer is A. Kenil is saying the answer is C. Okay, guys. So you know that whenever we are talking about the Mohr circle, you know that for the Mohr circle of stresses, we are having sigma here and tau here. For the Mohr circle of strain, we are having sigma here and gamma by 2 here. Okay, so my dear, as they are saying that the shear strain is equals to 12 into 10 to the power minus 6. So this is the state of strain which is given to us, and they have given you the value of strain. So when this is the case, you know, Mohr circle will be going to be like this. And my dear, if Mohr circle is going to be like this, you know, if this is going to be the gamma, gamma by 2 is going to be 6 into 10 power minus 6. So this point is going to be 6 into 10 to the power minus 6. this is going to be minus 6 into 10 to the power minus 6. So my dear, if you see the diameter, it is going to be 12. So the answer is going to be 12 into 10 to the power minus 6. So those who know how to draw the Mohr circle, for them this question is very, very, very easy. Piyush ji, you got it or not? Ravi Gupta, C. Pranjal Gupta, C. Very good, guys. So you guys are doing really well. So tell me, is there any doubt in this question? Then we are moving to the question number 2. Yes. Wonderful, guys. Wonderful. So guys, the next question is related to, you can say, simple stress and strain. This question was pending from the first class. Okay, because in first class we discussed some theory also. So because of that, this question was pending. So you can see a tension bar is found to taper uniformly from D minus A to D plus A. So there is a taper bar whose diameter is varying like this. And my dear, you can see here the diameter is D minus A and here the diameter is D plus A. And my dear, they are saying Young's modulus, obviously calculation of Young's modulus, the percentage error involved would be. So they are saying that percentage error, and they are saying that this is the actual bar. If the mean diameter is used in the calculation of Young's modulus, what do you mean by that? My dear, it means that actually it is taper bar, but they are considering it to be a prismatic bar whose diameter is equals to the average of these two diameters. Means it is going to be equals to D minus A plus D plus A divided by 2. So the answer is going to be D. Is it clear, guys? So the point is, the reality is this taper bar and the calculation are done using this prismatic bar. So obviously errors would be there, because you know for taper bar the formula is different, and my dear, for this prismatic bar the formula is different. So they are asking about the percentage error involved. So I would like to say, guys, you already know that delta taper formula is 4PL upon pi E, that is D1 D2. So if you are going to put the values, it is going to be 4PL divided by pi E D minus A D plus A. And you know delta actual, okay, delta actual is delta taper only, because the reality is taper bar only. Very good. Many of you have already given the answer as A. Sir, SOM is required, summary, practice, PYQ, I think. Dear, obviously whenever we are talking about the strength of material, this is learned through questions. So here we are doing the question other than PYQs, because for PYQs already sessions have been taken by me on the previous weekends of the last month, I feel. Okay, I have taken the strength of material mechanical question, civil question, and XC question I will be taking after 1 to 2 weekends. Okay, once the SOM is completed here, then I will be taking XC questions also. So my dear, delta actual is this, but what you are assuming it? You are assuming it to be a prismatic bar. For prismatic bar, 4PL by pi E D square is the formula. So my dear, you know this time 4PL pi E D square, D is also capital D. So 4PL by pi E D square. So my dear, you can see in this complete both the cases, load is going to be same, length is going to be same. So they are saying the calculation of Young's modulus, means calculation of Young's modulus of calculation of deformation. They are going to give you the same kind of errors only. Okay, so they are saying the error introduced is. So you will say actually is the taper bar, but you are assuming it to be prismatic bar, divided by the actual one into 100. This will give you the percentage error. This will give you the percentage error. This type of question I have previously asked in some of the examination. So Piyush ji also have given the answer as A. You will be putting the value 4PL upon pi E D square minus A square minus 4PL pi E D square divided by 4PL pi E D minus D square minus A square. So guys, you can see when you will be doing this into 100, you can see we are having 4PL upon pi E common, 4PL upon pi E common, 4PL upon pi E common. So when you will be solving this, you will be getting 1 by D square minus A square minus 1 by D square divided by 1 by d square minus a square, okay, into 100. So after solving, my dear, what you are going to get, I am telling you, you are going to get here 10a by d ka whole square. So the answer is going to be 10a by d ka whole square. Okay, so Bhavya is asking, sir, we are asked error in calculation. Dear, yes, you are correct. But I am saying you one thing. If you see this delta t, delta actual and Young's modulus. So my dear, if delta t and Young's modulus we are talking about, they can give you the question in two ways. Either they will be saying the material is same, and when the material is same, Young's modulus is going to be cancelled out, but deltas are not same. Otherwise, they can say you that deltas are same. Then what would be the error in Young's modulus? So you will take E on this side, delta T on that side. So then also the answer will remain the same. So there is no need to change, because when they are asking the error in E calculation, you just need to take E here and delta T here. Because if E they are saying, it means delta they are taking equal. So then only you can solve. Okay, Bhavya, I feel you got it. Wonderful, dear. बहुत ही बढ़िया, शानदार. Okay, guys, this is a wonderful question. A sample of a metal is tested in tension and it is found that there is a strain of 0.0080 at a corresponding stress of this. Okay. On the removal of the load, a permanent strain of this is found to be present. The value of, yes, modulus of elasticity. This is a wonderful question, my dear, and this is related to stress strain diagram. And if I show you that from where the question is being asked, actually, if you are saying loading is going like this, I am giving you hints so that those students who don't know, they can also solve with me, and those who know, definitely they can try by their own. So this value is given as 450, my dear, and this value is given as 0.0080. And you know, when unloading happens, it will be following the same curve and the slope is going to be same for both. And you also know tangent theta is nothing but the Young's modulus. And he is saying that when this is loading, this is unloading curve, this is the permanent strain which is left with the material, and it is given to us 0.0015. It is 0.0015. You need to find out Young's modulus. Young's modulus is nothing but tangent theta. And it is nothing but, if this is A, this is B, and this is C. So it is nothing but AB by BC. Now you need to give the answer. So my dear, why I am giving the hint? Because this is learn through question. So those students who already know the concept, they can try the question directly. They need not to wait for my hint. The student who don't know about the concept, I am giving you the concept here, and then you can solve and get the answer. Like Abhimanyu Singh, Midun, Piyush ji have given the answer as A. And I feel Bhavya also have given the answer as A only. So guys, do like and share this session, because this is a very, very important session. Today's topic itself is very, very important. Okay. Wonderful, guys. So I will tell you that. So you are getting 6.92, and I would like to say the answer is yes, it is correct. So 6.92 into 10 to the power 4 is correct. You can see this total is 0.0080. This is 0.0015. So BC is this minus this. Okay. So you will write it is 0.0080. Okay. First of all, AB is 450 divided by 0.0080 minus 0.0015. So the answer is 6.92 into 10 to the power 4, and it is going to be MPa. A is correct answer. बहुत बढ़िया इमोन कलिता, बहुत बढ़िया मधुवंशी. Wonderful, guys. Now this is question number 4, and it is once again from the taper bar. Why I am taking more questions on taper bar? Because this is the topic which is untouched by GATE till now. So soon they are going to touch it. Okay, because ESC have asked, GATE XC have asked, but mechanical civil have not asked. So they are soon going to touch this topic. Kenil sir, always having a fear of numerical answer type question, how to fix it? Dear, this is the only thing, practice. Okay, so practice, practice and practice. That is going to remove all your fears of the examination. Whether it is NAT or it is MSQ or it is MCQ, it doesn't matter. If your concepts are clear, type of question cannot make you puzzle. If your concepts are not clear, then only that kind of issues will arise. Okay, Bhavya is already, I feel, have given the answer. So this time he is asking, a tapered rod shown in the figure is subjected to an axial pull P. The ratio of extension based on the actual calculation and based on average diameter. So this time they are asking about delta actual divided by delta theoretical. You already got it that actually it is a taper bar. So actually it is a taper bar. So if you are asking about the actual deformation, it is going to be 4PL upon pi E D1 D2. And if you are talking about the theoretical discussion, it is taking average diameter 4PL upon pi E D1 plus D2 by 2 ka whole square. So guys, you just need to find out the ratio of actual to the theoretical. Okay, Kenil is saying 4 by 3 means D only. Madhuvamshi is saying D only, Bhavya is saying D only, Kenil is saying D only, Piyush is saying D only. So guys, yesterday I shared the PDF. Everybody is getting PDF on time or not? If you have any doubt, you can ask on the Telegram channel. Handwritten notes are already available on the Telegram channel. If you have not joined yet, join my Telegram channel, Mechanical by Dheeraj Sardana. Okay? Very good. Pranjal Gupta have also given the answer, and the answer for this is D, no doubt about that. Okay? So my dear, when you will be solving this, you will be getting 4PL upon pi E. D1 D2 is 0.15 into 0.05 divided by 4PL upon pi E. This is going to be average of that. So 0.15 plus 0.05 divided by 2. So guys, this ratio will be coming out to be 1.33. D is going to be the right answer. Is it clear? So blue color is fine, visible to all of you? Yes. Otherwise, I will change the color. Don't worry. So guys, this is the question pending from bending, but this is the only previous year's question I have considered here, because this type of the question have been asked only once by the GATE, and I am sure soon it will be coming in the exam. Very good, Abhimanyu Singh. So this is the only previous year's question I have in the complete series of SOM. Till now we have discussed almost 75 to 80 questions, and till now we have not even used a previous year's question. Okay, like yesterday also, today also. Very good. Bhavya have already answered it because it is PYQ. So Bhavya would be remembering the answer for this. Wonderful, guys. So my dear, this is a beam with the cross section given below is subjected to a positive bending moment. Everybody would be knowing positive bending moment means a sagging moment. So it is going to be sagging, causing compression at the top of 16 kilonewton meter acting around the horizontal axis. Determine the tensile force acting on the shaded area of the cross section. Those students who are new to this series, I would like to tell you that on Sunday we have a quiz on the Byjus Exam Prep app of the complete SOM, what we have discussed from Monday to Saturday. Top 3 students would be given prizes. So be ready for that quiz, and questions would be coming similar to whatever we are having in these sessions. If you are looking for these sessions properly, you are going to get a very good rank there, and top students would be getting the prize. भव्या, कल का सेशन के क्वेश्चन में से यस हाँ, बट कल हमने नहीं किया था भव्या इसको. Yes, Balraj, it is for civil and mechanical both. Sachin, whenever you find any such doubt, you can definitely ask me on the Telegram channel also, and if you will say, I may be sharing you some of the video link which we have taken on this channel, which may clear your concept, or I will be teaching you live also. So whatever you feel the difficulties, just share with me on the Telegram or WhatsApp. I will share you the WhatsApp number. You can talk to me there. I will be helping you live, don't worry. Great. So guys, whenever you will see this question, how to do that, I am telling you. You know that if this is the beam, then you know that if we see the bending stress distribution, we would be given the cross section which was already mentioned previously. So let us say this is the cross section. And you know, if you are going for a positive bending, means this type of bending moment is applied. For this type of bending moment, my dear, bending stress distribution will be coming like this. This will be the bending stress distribution. You know, at the top fiber we will be having the compressive stress, at the bottom fiber we will be having the tensile stress. You know that stress into area is the force, and you need to find out the force bear by this part of the cross section. So if they are asking force bear by this part of the cross section, you know force is equals to stress into area. So if you are talking this area as A, you just need to multiply the stress with the area. But the point is, my dear, stress is not going to be constant throughout the area. At this fiber, stress is 0. At this fiber, stress would be having some value here. Let us say that value is sigma. So my dear, when it is not constant, it is varying linearly. If the variation would be of any type, it may be very difficult for us to calculate the stress. But whenever you find linear variation, for such cases we are defining it as sigma average into area. And here what is sigma average? You know, average is defined as, my dear, sigma maximum plus sigma minimum divided by 2. You can see sigma minimum is 0. So you can write sigma maximum is sigma. So it is sigma plus 0 by 2. It is sigma by 2. But the point is, what is sigma? What is sigma? Balraj, dear, I would be announcing that class on Friday. Okay, because that is on Sunday. So it would be in the evening, either 4 or 5. The time I will be announcing at that time, and even you may be getting tomorrow a short on this channel where it would be also, I can say, announced that what would be the prizes for first, second and third. So that would be shared. Don't worry. Just connect with us on the Telegram channel Mechanical with Dheeraj Sir, and also on this YouTube channel. So you will be getting the information for that. Or maybe tomorrow I will be telling you all the information. So don't worry about that. Okay. So my dear, if you see this, this is sigma by 2. So my dear, now what is sigma? You know, sigma can be found out as m into y divided by INA. So my dear, you know that y is the distance from neutral fiber. This is going to be the y. Let us see what is the bending moment applied. Bending moment applied is 16 kilonewton meter. So I will be putting the value here, that is 16 into 10 to the power 3, that is Newton into meter. Okay, you can see the fiber distance. The distance is from neutral fiber, it is given as 25 mm. So y is going to be 25 mm, my dear. Let us put the value 25 into 10 to the power minus 3. It is becoming in meter now. INA is BD cube by 12. So you know that here width is given to you as, this is width which is 100. This is depth which is 150. So you just need to put this value, and my dear, whenever you will be putting this value, you will be getting the value of sigma. So I feel it will be coming out to be 4.22 MPa. Whenever you will be putting here and this value here, you will be getting force as sigma average is sigma by 2, 14.22 divided by 2 into the area. What is the hatched area? This area is 25 into 50. Let us put the value, that is 25 into 50. Putting this, you will be getting 8.98 kilonewton. That is the procedure of the problem. So whenever we are talking about learning through questions, I am showing you a particular type of question. I am solving with the way. So if you remember the equation, you just need to understand how to solve such kind of question. Kenil sir, what if we do not take average and take at a distance y from the CG of the, dear, actually the point is, whenever we are talking about the stress distribution, whenever anything is having linear distribution, then we always use the average value. Okay, because force is defined as stress into area, and stress is defined at a point, and whenever we are taking the point at any fiber, then with respect to the y, the stress is going to vary linearly all the time. Okay, so that is our assumption also whenever we are using the Hooke's law. You have studied in the bending, so that is why we are not changing the definition. Force is stress into area. So what you are saying is that why not we are taking average and take a distance of CG of the given area. So my dear, that we cannot take, because force, when you calculate, it is stress into area. Okay, it is not that you can say that area का centroid से distance ले, it is not like that. It is defined as stress into area. So we cannot change the definition. Sir, why not sigma minimum is minus sigma? Dear, you can take in that way also. You can take in that way, but you must understand the loading given is sagging. In sagging, it is going to be compressive, it is going to be tensile. So this value is always plus sigma here. Okay, then also you will be saying it is 0, it is plus sigma only. Minimum is 0 in that way. Is it clear? Pranjal, I feel your doubt is clear. Is it clear, guys? Yes, Pranjal Kenil, please tell me that. Sir, कर्नल के क्वेश्चन कॉमन है क्या गेट में? डियर, कर्नल के क्वेश्चन गेट में आए ही नहीं है कभी मैकेनिकल में. हाँ, सिविल में भी एक ही बार आया है. It have been asked only once, but I will be doing that in the class for sure. Don't worry. So guys, question number 6 now. This is once again from principal stresses. In a stressed body, an elementary cube of material taken at a point with its faces perpendicular to x and y. Tensile stress is equals to 15 kilonewton per centimeter square and 9 kilonewton per centimeter square are observed on these respective faces. What they are saying is, they are saying there is a point which is shown by a rectangle and those two stresses are given to us. This stress is 15 kilonewton per centimeter square and this stress is 9 kilonewton per centimeter square. And they are saying that shear is also there, which is 4 kilonewton per centimeter square. So guys, as this is a CTQ type of session, so that's why I am explaining the concept with the help of questions only. So this is the name of the series like that. Good evening, Bhai Abhishek. Thanks for joining. So guys, you can say shear is 4 kilonewton per centimeter square. The magnitude of principal stress at that point. I feel everybody would be knowing about the formula. Sigma 1, 2 is sigma xx plus sigma yy by 2 plus minus square root of xx minus yy by 2 का whole square plus tau xy का whole square. This is sigma 1 and sigma 2. Yes, solve it, guys. Kameshwar, fine, B. Madhuvamshi is saying B. Kenil is saying B. Pranjal is saying B. Thanks, Abhishek. So guys, I feel all of you are saying the answer to be B. And let me have a cross check because I already solved for you guys. And the answer we are going to get is, yes, 17 and 7. Great, Piyush Ji. Great, guys. So answer is going to be B. So this is the formula you need to use. You know that this is the value of sigma xx. This is the value of sigma yy. This is the value of tau xy. Yes, Sachin Gautam, please tell me, are you clear about this concept or not? Wherever you find difficulty, just say, sir, please explain this concept. I will explain it. Yes, I cannot go for derivation, but definitely I will tell you that what are the things defined and how you need to solve. Good evening, Kameshwar. Welcome to this session. Imon Kalita, very good, dear. So Imon, yes, always, if you find any doubt, you can also ask. Yes, very good, guys. Wonderful. So let us move to the question number 7 now, guys. Question number 7 now. So the state of two-dimensional stress acting on a concrete lamina consists of a direct tensile stress. So they are saying sigma xx 1.5 Newton per mm square and a shear stress 1.2 Newton per mm square, which cause cracking of concrete, then the tensile strength of the concrete would be. So my dear, how to solve this? Fine, Sachin. So how to solve this, guys? How to solve this? You can see sigma xx is given, tau xy is given. Sigma yy is not given. So this state of stress is like this. Sigma xx, tau xy. Okay? So you need to find out strength means, what is strength? The maximum value of stress. Yes. So solve it, guys. I am waiting for your answer. Yes. You know the same formula would be used. 1, 2 xx plus yy by 2 plus minus square root of xx minus yy by 2 का whole square plus tau xy का whole square. It is mentioned that sigma yy is 0 because there is nothing mentioned. Sigma xx given, tau xy given, so it means sigma yy is 0. Put the value, get the answer. Let us see how many of you give the right answer. Very good, Piyush. Polaki Deepak. Yes, actually you cannot say it one dimension. This is two dimensional only now. Sir, shear stress का direction identify बताऊंगा कामेश्वर. Don't worry, I will discuss that also. That also I will discuss. Okay, wonderful guys. बहुत ही बढ़िया. Midun is saying C, Jishnu is saying C, Kameshwar is saying C, Piyush is saying C, Kenil is saying C. बहुत ही बढ़िया guys, बहुत ही बढ़िया, मजा आ गया. Dear, actually whenever you are having both normal and shear, it becomes combined loading. Yes, because shear is coming in x plane and y direction. So both x and y are used, na? So actually it is combined loading, not even biaxial. It is combined loading because both normal and shear are there. And yes, it is 2D combined for sure. बहुत ही बढ़िया. So guys, the answer for this is coming out to be, let me check. Yes, C is the correct answer. 2.17 is the correct answer. So when you will be putting the value, sigma xx is 1.5, sigma yy is 0. It is going to be plus minus square root of. It is going to be 1.5 minus 0 by 2 ka whole square. And it is going to be plus 1.2 ka whole square. So my dear, when you will be solving, you will be getting the answer to be as 2.17 Newton per mm square. Yes. Because we need to find out the strength, tensile strength. So maximum value is going to be our answer. Sachin, I feel you got the same mistake because one is plus, other is minus. Plus will give you the maximum value, that will give you the right answer. That is 2.17 because they are asking the strength. Strength is the maximum value of stress. Is it clear? Very good, Abhishek. बहुत ही बढ़िया. So guys, now we are moving to question number 9. And this is a very easy question. Let us see how many of you give the answer. Abhishek, actually this is a practice session, so it is for mechanical, civil, XC, all the three branches. If you see the level of question of yesterday class, you will be getting to know that it is for all. Okay, just check the level of the question. Yes, Sachin, that is coming actually the second value. Okay. So second value is going to be the same what you are saying. The first value is 2.165. So we need to answer the maximum one. And guys, do like and share the session. I want more and more people to come here because this is a very useful series. Bhavya is saying the answer to be C. Sachin, okay fine. Madhuvamshi is saying 0. Sachin, you got it or still any doubt? If you have doubt, please tell me that. Okay. Pranjal, don't worry dear, don't worry. With the practice you will also be becoming fast. Okay. So if you are weak in any subject, just do more and more practice. And this monsoon crash course is for the same. Practice, practice and practice. Okay. Like you have seen the movie entertainment. The same way, practice, practice and practice. Kenil is saying 0. Piyush is saying 0. Great. Very good. Great. Fine. Polaki Deepak. So keep on joining live all the time. You will get to know new points. You have missed yesterday and day before yesterday session also. Try to solve question of yesterday session also whenever you get time. Don't miss this monsoon crash course classes. We are discussing wonderful level of problems. Let us see this question. This is a tricky one. And this can come in the GATE exam. At a point in a piece of stressed material, stresses are sigma x is this, tau xy, tau yx is this. They are saying although the value of alpha, beta are not known, yet the principal stresses are equal to each other. What is the radius of Mohr circle? So my dear, this is given to us. Principal stresses are equal to each other. Yes, so my dear, when principal stresses are equal to each other means sigma 1 is equals to sigma 2. whenever we have sigma 1 is equals to sigma 2, and they have also mentioned that is equals to 5 kilonewton per meter square. This is equals to 5 kilonewton per meter square. Means they are equal in magnitude as well as equal in direction. That's why they are mentioned the same, 5 kilonewton per meter square. You know, my dear, when we get sigma 1 and sigma 2 to be equal, you know, if you are going to make any Mohr circle, then my dear, extreme value of Mohr circle will give you sigma 1 and sigma 2. When this 1 and 2 will become equal, when dia of Mohr circle will become 0 or the radius will become 0. So when radius is going to be 0, then only it can happen that you get sigma 1 is equals to sigma 2. So the answer is C. So there is no role of alpha, no role of beta. So by just looking at the question, 90% of the students are going to leave this. Why? They will feel how to solve alpha beta. There is no need to solve because this is a tricky question. The answer for this is C. You can expect this type of question in the upcoming GATE exam, guys. Yes, Abhishek, this is the hydrostatic state of stress. This is also the state of stress in thin spheres. Yes, guys, solve this question now. This is once again from principal stresses. You can see, my dear, this x face is given to us and the angle is given in anti-clockwise direction. Theta is 25 degree. You can see, if you see the loading, sigma xx is given as 60 Newton per mm square. Tau xy is given as 26 Newton per mm square. These are the data given. Try solve this. Very good, Midun. Two planes AB and BC which are at right angles, shear stress of 26 Newton per mm square, while the plane AB carries a tensile stress of 60 Newton per mm square. Find the normal and shear stress on plane AC inclined at 25 degree anti-clockwise. Those who don't know the formula, don't worry, I am going to help you guys. The formula used for this is going to be sigma theta, sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos to theta plus tau xy sin to theta. You know theta is 25, tau xy is 26, okay? So in that way things are given to us. What is tau theta? It is sigma xx minus sigma yy by 2 sin to theta minus tau xy cos to theta. These formulas are valid only when theta is anti-clockwise to the x face. Solve this question, guys, and do like and share the session, guys. Why you are so confused? Because when you will be liking the session, then only we will get to know that whether these sessions are useful for you or not. Yes, guys, to get the PDF of this session, just join me on the Telegram channel Mechanical by Dheeraj Sardana. Very good. Bhavya is saying 69.2 and 6.27. According to Bhavya, the answer for this question is coming as A. What about others? Midun is also saying the same. Abhimanyu Singh, what would be the answer for this question? Piyush is also saying the same. So guys, this is the formula based question, and in GATE this type of questions are coming. Kenil is also saying the same. Sir, for pure shear case, principal stress at 45. Yes, Deepak, and we are having the question on that topic also. So don't worry about that. Okay. अभिषेक वेरी गुड डियर, बहुत ही बढ़िया. जिष्णु बहुत ही बढ़िया. मधुवंशी बहुत ही बढ़िया. इमोन कलिता बहुत ही बढ़िया. तो what I found is you guys are stronger on the formulas. Everyone have given the right answer. Very good, Kameshwar. बहुत ही शानदार. Answer would be A, guys. Now question number 11. The principal stress at a point on a body subjected to a state of plane stress are 10 MPa and 20 MPa. Sigma 1 is 10 MPa. Sigma 2 is 20 MPa. They are asking the magnitude of shear stress on a plane at which normal stress is 12 MPa. Ha Bhavya, you are correct. Okay, let me check. Yes, you can say actually this is 69.6, but you will get 69.2. Generally this much closeness is not there in the options, but if it is, definitely you need to take care of the calculations. Yes, very good Bhavya, very good observation. So here they are giving you the principal stresses, my dear. They are giving you that. And they are also saying that they want the magnitude of shear stress on a plane at which normal stress is 12 MPa. So whenever you know sigma 1, sigma 2, you can make the state of stress. This is sigma 1 because both the principal planes are perpendicular to each other. This is sigma 2. And you can also use them as this as sigma xx, this as sigma yy. So when you will be using this, you know the formula of sigma theta as sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta. Okay, and you know 12 MPa it is given to you, sigma xx known to us, sigma yy known to us. Okay, and you know tau xy is 0 here. Using this you can find out the theta, and then you can find out tau theta as sigma xx minus sigma yy by 2 into sin 2 theta minus tau xy cos 2 theta. Yes, Sachin Gautam, are you getting it or not? मोहर सर्कल से भी कर सकते हो. Yes guys, very good Sachin, बहुत ही बढ़िया. So what you need to do, my dear, sigma 1 and sigma xx are same, sigma 2 and sigma yy are same, tau xy 0 because there is no shear. So if you see this is known, sigma theta is 12. You can find out theta from here. Getting theta from here, put the value of theta here, you will get the value of tau theta. This is the analytical method. Those students who don't know about Mohr circle can also solve this. But yes, from Mohr circle it can be done very easily. That also I am telling you. Actually, I have separately 3 questions specially based on the Mohr circle. But still, as many of you are saying, I am telling you by Mohr circle also. बहुत ही बढ़िया. I feel all of you are giving the answer as 4. Am I correct? And you guys are very much correct. The answer for this is 4 MPa. Yes guys, is it fine for all? Wonderful guys, wonderful. Mohr circle में एक triangle. Yes, very good Abhishek. So let us see the Mohr circle. I already told you, whenever we are talking about the Mohr circle, principal stresses sigma 1 and sigma 2 are mentioned to as 10 and 20. So it means whenever you will be making the Mohr circle, the extremes, this is 20 and this is 10. Extremes are nothing but the principal stresses. So my dear, the center would be coming at 15. And you know that, my dear, that you need to find out the shear stress at a plane where normal stress is 12 MPa. So you know that the normal stress will be having the value of 12 here, and the point related to this is here. So if I say, my dear, this is the radius of Mohr circle, then this will be the radius and this value is 12. So obviously this value is going to be 3. This value is 5. And this value will give you the tau xy. Okay, so my dear, when you see this triangle, it is very easy to solve. This value is 3, this value is 4. So what would be this value? 5 MPa. Now those students who would be having any doubt on this, just search for a session Mohr circle by Dheeraj Sardana on this YouTube channel. There are 2 sessions, watch any of them. In 1 hour, your Mohr circle would be clear. Okay, so you can use that if you want to learn from basics the Mohr circle. But in this series, we are going to learn through questions, guys. बहुत ही बढ़िया. Wonderful, guys. So the answer for this is 4. Let us solve the question number 12. An element in plane stress is subjected to stresses sigma xx minus 50, tau xy 40. If the larger principal stress for a given element is 30 MPa tensile, then the stress sigma y would be. So sigma y is not known to us, but sigma 1 is given to you. Very good. This is a wonderful question, guys, and let us see how many of you give the right answer for this. You must be knowing sigma 1 is xx plus yy by 2. Let us say 1 to both. xx minus yy by 2 का whole square plus tau xy का whole square. Tau is known to us, xx is known to us. You just need to find out the yy, and sigma 1 is also given to us. Sigma 1 is mentioned as 30 MPa. So you just need to find out sigma yy. Okay, no issue Abhishek, it's fine. It's fine. Solve it, guys, and tell me the answer for this. You need to find out sigma yy. This simple formula you need to use. Wonderful, wonderful. And guys, do like and share the session. Let others also come to the session so that they can also get these variety of questions. If you will search for this question, it is going to be very difficult for you because they are from multiple sources. Bhavya, what would be the answer? Abhishek, Kenil, Madhuvamshi, Piyush ji, Jishnu, Pranjal. Yes. Only sigma yy is unknown to us. Put the value here 30 minus 50 plus sigma by 2 plus minus. What is sigma xx? It is minus 50 minus sigma by 2 का whole square plus 40 का whole square. Just take this on this side, square both the sides, you will get the answer. Yes, it is having lengthy calculation. So guys, I already told you in GATE also they are giving 2 to 3 questions which requires a lot of calculations. You always need to search whenever you find such question, solve them in the last. So why I am taking such questions? Because when you will see the GATE paper, these types of question will be there only. So if you have practiced them, you would be knowing just by looking at the statement that this question is going to be lengthy. Just attempt them in the last. And those people who are preparing for HPCL, tonight 11 PM we are going to join, me and Rakesh sir would be there, and that session is going to help you how to prepare for HPCL, and from this weekend we are going to start the series for you on this channel also. You are going to get a quality content from our site for HPCL, guys, and those also will be free for all, anyone can attend. बहुत ही बढ़िया भाई. So answer क्या आएगा? Midun, you are very close actually. Bhavya, I feel you have done some mistake. So whenever you will be calculating the sigma y for this case, yes, sigma y would be coming out to be 10 MPa. Solve it. It's only calculation. There is nothing where I can help you here, because I can help you in just concepts. Calculations, you are the person who is going to do. Wonderful, wonderful, guys. So Midun, I feel you have done some mistake of 0 only. Bhavya, find out your mistake. Actually, I feel you have done some mistake where divided by 2 is required. Balraj, it is also going to be for all branches. Mechanical, civil, is doubly instrumentation. Okay? For all the branches where seats are there, sessions would be there. Great, great, great. So the answer will be 10 MPa. Wonderful. So Bhavya, that's great. So guys, those who are feeling difficulty in calculation, for that only this series is na, to tell you where you are weak, and let's practice on those areas. Very good Pranjal, very good Madhuvamshi. Great Kenil, great. So the best thing is you go to your mistake. Now it's time to take rest. Some easy question. Yes, now it's time to check your conceptual, what you know about the principal stresses, about your concepts. So guys, the question is, when Mohr circle reduces to a point, which of the following stress components are acting? When Mohr circle reduces to a point, they are saying like equal normal stresses, unlike normal stresses, only shear stresses, none of the above. It's the real check of your concepts. Very good, Abhishek. Sachin, here you can answer easily. Yes, welcome back, Abhinav Tiwari. So answer is A. Sachin is saying A. Piyush is saying A. Abhishek. Okay, Imon Kalita, Midun, Madhuvamshi, Ravi Gupta. बहुत ही बढ़िया guys. सभी लोग एक ही स्वर में बोल रहे हैं A. बहुत ही बढ़िया, शानदार. So guys, obviously this is the state of stress which Abhishek Sahu have mentioned as hydraulic state of stress. Actually that is compressive, but here it is tensile. I have shown. So either this or this. Whenever you see this state of stress, then my dear, we are having the answer for this is going to be A, because here you will be having all the principal stresses equal and Mohr circle will become a point. So all the principal stresses at all the principal planes would be same. I am fine, Abhinav. Do connect with me tomorrow. Let us discuss about your preparation and all. For a plane stress element, maximum possible number of independent stresses component. This is going to be a wonderful 1 mark question for GATE paper. Very good, Abhishek. Yes guys, do like and share the session. Number girna nahi chahiye, just solve it. I am coming with very wonderful questions for you, and you are going to see the similar question in the GATE exam. So why to miss that opportunity, guys? Abhinav means let's have a call. That's what I was saying. Okay. Bhavya is saying 2D or 3D. So dear, when it is already mentioned plane stress, you shall not ask this question. Great, Abhishek. Thanks for that. Jishnu is saying 3. Piyush is saying 2. Madhuvamshi 3. Kameshwar 2. Pranjal is 3. Madhuvamshi, if that I will be telling, then how you will answer. Sachin is saying 3. बहुत ही बढ़िया. So guys, you must be aware of that. Whenever we have plane state of stress, the combined loading have this. This is the state of stress under combined loading. So my dear, maximum possible number of independent stresses. This is sigma xx. This is sigma yy. Tau xy, tau yx. So my dear, if you see this, you know that in the first class I told you tau xy and tau yx are equal. So there are total of 4 components: sigma xx, sigma yy, tau xy and tau yx. So out of 4, if these 2 are equal, so 1, 2 and 3. So these are 3 independent components. So the answer for this question is going to be 3. बहुत ही बढ़िया guys. अब आएगा मजा. Now we are going to get a wonderful question, guys. Let us see how many of you give the answer for this. Yes, Piyush ji, but they are asking total, na? They are not asking how many normal component. Okay. Yes. So the row set, this time the question is from strain gauge row set. Yes. Wonderful guys, बहुत ही शानदार, बहुत अच्छा जा रहे हो यार आप लोग. Just tell me the answer for this question. The students who are going to give this answer easily, their concepts are really great. Okay, so you can see, my dear, I am giving you a small hint there. The students who know the concept, they will understand what I want to say. This strain gauge and this strain gauge, they are perpendicular to each other. And this strain gauge and this strain gauge are perpendicular to each other. So 1 and 3 are perpendicular. 2 and 4 are perpendicular. Yes, Abhishek, Piyush, Balaraj, Sachin, Bhavya, Kenil, Pranjal, Madhuvamshi, Midun, Kameshwar, Jishnu. कहाँ हैं सबके सब बताओ? What would be the answer for this? Midun is saying C. बहुत बढ़िया, wonderful dear. Bhavya, Kenil is saying B. What about others? Okay, so now I am giving you the hint again. You know the summation of stresses on two perpendicular planes are always equal. You always write sigma 1 plus sigma 2 is sigma xx plus sigma yy is sigma theta plus 90. So if you have any two planes which are at perpendicular to each other, the summation of stresses at those planes are always going to be constant. So my dear, the same principle we can apply on the strains. So you can write in the same way epsilon 1 plus epsilon. Okay, let us see what are perpendiculars. Epsilon 1 and 3 are perpendicular, 2 and 4 are perpendicular. So 1 plus 3, 2 plus 4. 3 are given, 1 you need to find out. What easier than this can be asked? But by looking at the figure, it seems to be very, very difficult question. Many people would be applying the equations of theta 45 and all. No need to do that. So you can see, my dear, epsilon 1 is 428, epsilon 2 is minus 65, epsilon 4 is 183. Just need to put the values. So you will say 428. This is 428 positive, epsilon 2 is minus 65 plus 183 minus 65 plus epsilon 4. So epsilon 4 minus 310 microns. Wonderful, guys. Sure, Abhinav, you can do tomorrow after 10, 11, before 5. So the answer for this is nothing but C. Everybody got this or not? So guys, those who were not knowing about this concept, this is the benefit of the solving problem. You got this concept now, that next time whenever you find such kind of question, you will be able to do. That is the advantage of this monsoon crash course. Monsoon rankers crash course. Okay. Next question. And guys, the best thing is, such kind of thing is not available in the market. So whenever you are learning from here, this is for free for all. You are going to be the rankers. Obviously, yes. Very good, Imon. Question number 16. So today we are going with a very good speed. Very good speed. In an elastic material, the principal stress are, you can say sigma 1 is given as 2 sigma 1. Okay, just take it as sigma rather than take sigma 1 all the times. So let us take it as sigma 1 is 2 sigma. Then they are saying sigma 2 is sigma. Sigma 3 is minus sigma by 2. Because those two are tensile, this is compressive. Maximum shear stress developed in the member. So you need to find out maximum shear stress. You know it is given as maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, sigma 1 minus sigma 3 by 2. Always mode is there, so you need to see the magnitude only. solve this, guys. So this is once again a type of question. When you see this, you get the idea how to solve it. Very good. Bhavya, I feel in the starting you have find out the in-plane shear stress. Bhavya is saying C. Kenil is saying C. What about others? Midun is saying C. Madhu Vamshi is saying C. बहुत ही बढ़िया. So guys, do like and share the session. Abhishek is saying C. Still many questions are there. So I feel everybody is aware of how to solve. What would be the answer? Ravi Gupta, Jishnu, Abhinav. So after some difficult and lengthy question, we have some normal questions also, but they are also of new type which have not asked in GATE much. Sigma 1 minus 2 by 2. So 2 sigma minus sigma by 2 is sigma by 2. 2 minus 3. Sigma minus sigma by 2 by 2. Sigma minus of minus sigma by 2 by 2. So this is going to be 3 sigma by 2, 3 sigma by 4. Yes. Similarly, that is 2 sigma minus of minus sigma by 2 by 2. This is 5 sigma by 4. The answer is C. बहुत ही शानदार गाइस, बहुत ही बढ़िया. Question number 17. Question number 17. The maximum shearing stress developed in the bar subjected to a tensile stress sigma in the figure. Yes guys. Once again the same question. This time you just need to understand sigma 1 is sigma, sigma 2 and sigma 3 are 0. And you are asked what is tau max. अरे इससे आसान क्या होगा? Once again you will say sir maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2 and sigma 1 minus sigma 3 by 2. So as in this case this is a uniaxial type of loading. Yes. Very good. Very very good. बहुत ही शानदार गाइस. इमोन कलिता B, Abhishek Sau 0.5, Piyush Ji P, मिदुन B, मधुवंशी B. हाँ डेफिनेटली मोहर सर्कल से भी कर सकते हैं आप. So my dear, if you are going for Mohr circle, you know when we are going for Mohr circle, this is the state of stress. If you are looking at X phase, only normal stress is there. So point A will be coming out to be sigma comma 0. Y phase have nothing. Point B will be 0 comma 0. So my dear, one point is going to be this, other is going to be this. This would be the Mohr circle, and radius of Mohr circle is the maximum shear stress. So you can see the radius of Mohr circle is the maximum shear stress. So the radius, if this value is sigma, radius is sigma by 2. Yes. This is not a pure shear state of stress. Yes. बहुत ही बढ़िया. Let us see the next question, guys. Let us see the next question. Very good, Sachin. So you are getting the answers, dear. Why you are demotivated, sir? I am getting problem. If you find any difficulty in any question, stop me there and ask me. You are doing really well. So guys, you need to tell me this Mohr circle is true for how much of them or which of them. Okay. And here let us practice how to make Mohr circle also. Question number 18 we are reaching to, guys. Today we will be comfortably completing the question because we are left with 30 minutes more. So I have also shared the schedule to you guys. You need to be there till Saturday with me. Sunday we have a test. Try to be in top 3. Earn while you learn. पढ़ते हुए prizes जीत सकते हो आप. दोनों साइड से benefit. Very good. Midun is saying C. Bhavya is saying A. Bhavya is saying C then. Okay. Piyush is saying C. Madhu is saying C. Pranjal Gupta is saying C. Wonderful, guys. Kameshwar is saying C. So my dear, first of all, we let us see how to plot the Mohr circles. So one state of stress is given like this. So like Abhimanyu was asking, I feel, I don't remember, that how to see the direction. You can see, my dear, this force is trying to rotate the member in anti-clockwise and this is trying to rotate clockwise. So my dear, whenever we are talking about this value was whatever, let us say tau here, tau here, tau here and tau here. My dear, this is said to be X phase. This is said to be Y phase. Mohr coordinate system is taking sigma on x-axis, tau on y-axis. So if you say that what is the state of stress on the x phase, on x phase there is no normal stress. So you will say the coordinate of A is going to be 0, this is anti-clockwise, so minus tau. So this point will be coming here 0, minus tau. Look at the state of stress on the y phase. Once again, no normal, only shear, that is trying to produce clockwise. So the coordinates of B would be 0, plus tau. Because on x-axis sigma, y-axis tau is there. So 0, plus tau will come here. This is B. Next step is join A and B. Take AB as diameter and C as center. Plot a circle. This circle is a Mohr circle. This circle is a Mohr circle. Abhishek, this will go up to 7:30. And I would also like to tell you guys, in this series we are going to cover SOM, TOM, okay, production, industrial, fluid mechanics, thermal, HMT, means except engineering mechanics and machine design. All technical subjects would be covered for mechanical. For civil, OCF, fluid mechanics, strength of material, soil mechanics, environment, RCC. These are the subjects which are going to be covered. So guys, this is the Mohr circle, and you can see our Mohr circle given is also like that. So you can see that this value is going to be tau, this is going to be minus tau, this is going to be minus tau. So if this tau value is given as 2, that should be our answer. Here tau value is 1, this cannot be our answer. Here tau value is 2, so C is going to be our answer. Then what about this and this? You already know this is a state of stress similar to thin sphere. For such case, when this is 2, 2, 2 and 2, Mohr circle is going to be a point at 2. Similarly, if this value is 1, Mohr circle will be a point at 1. So I have drawn Mohr circle for all the states. Your answer is going to be C. Everybody clear? Madhuvamshi, all the topics. One topic every day. Like here we are doing the practice, but it would be LTQ. I will be telling you, teaching you all the things using the practice sessions only. If you want, first 30 minutes we can revise the formula. Okay, so this is once again the Mohr circle given to us. Mohr circle for certain stress system is shown the principal stress major and minor in MPA. You know, Mohr circle extreme points where they cuts on the x-axis, that will give you the principal stress. So you just need to tell sigma 1 and sigma 2 values. Yes, Kenil. Don't worry, Piyush ji. After completion of all those subjects, we will extend the plan for mechanics and MD, but that depends on your strength or your response, because we have seen for those subjects generally people are not coming. So that is the point. So we will see, if you guys are interested, we will extend the series for other 2 subjects. Even we have included mathematics and aptitude part also. So if you find it useful, just continue the class. We are always there to help you. We will add mechanics and MD, don't worry. Solve it guys, solve it. Very good. Solve this question. So I have given you the hint, my dear. This is the center of Mohr circle. This value is given as 150 to you. Yes. This value is given as 250 to you. Yes. If you see, this is one point, this is another point. So when this is the point, you can easily understand sigma xx is 250 MPa because this point is sigma xx comma tau xy. And this point is sigma yy comma tau xy. So sigma xx is 250, sigma yy is 0 and tau xy is 150. You need to find out the principal stresses. Very easy, guys. Okay, you have already given the answers. Bhavya is saying the answer to be, because you know how to plot Mohr circle. I told you, na? Like if you are given a state of stress like this. Okay, those who don't know how to plot Mohr circle, let me tell you in short, in brief. Let us say you have some value sigma xx here. Let us say you have some value sigma yy here. Let us say you have some value tau xy and tau yx here. So on x face you have normal stress as tensile and shear stress as anti-clockwise. And on y face you have sigma yy as tensile and this as clockwise. So you just need to plot these points. Let us say xx is more than yy. Then my dear, this point would be sigma xx minus tau xy. This point is A. Sigma yy plus tau yx. This point is B. This is sigma yy. Join AB, take center here and plot the circle taking this diameter. So these 2 points are given to you in the question. Very easily anyone can solve this. So if you see this, you will be finding out with the formula now. Xx plus yy by 2 plus minus square root of xx minus yy by 2 ka square plus tau xy ka square. Guys, please tell me, are you getting it or not? And please tell me that whether you are enjoying the session or not, because we have seen a number of new varieties today. Is it clear or not? Piyush ji, don't worry. I will be telling you how to solve engineering mechanics. Okay? So don't worry about that. This is the question of the day. This is the question of the day. Make 5 star to this from my side. I am expecting you are going to see this question in upcoming GATE examinations. I am writing here and I am very much sure on the day of the analysis I will be solving this question from GATE side. Okay, I am very much sure. So I am telling you this is a wonderful question. Okay, so let us see this. A circle of 100 mm diameter is inscribed on a steel plate before it is stressed, and then the plate is loaded as shown in the figure. Then circle is deformed into an ellipse. Determine major and minor axis of the ellipse and their directions. Leave the direction part. I just want major and minor axis of the ellipse. I am telling you how to solve this question. Don't worry. So my dear, just try to understand what is happening actually. I am telling you on the next slide. We are having a plate, guys. And on that plate, we are inscribing a circle like this. Now this plate is loaded. It is loaded like this. And because of loading, some strains and stresses will come into picture. So because of that, my dear, initially it was a circle like this. So when it was a circle, it was having the same radius from all the sides. Then my dear, this circle is getting converted into an ellipse. And for ellipse, this is going to be the maximum diameter. This is going to be the minimum diameter. Initially, all the diameters in the circles were equal. Later on, we have one diameter major, other minor. Other than these two, all the diameters will lie in between them. Okay. So, my dear, this is D major and this is D minor. And you need to find out the same. It is similar to maximum stress, minimum stress, maximum strain, minimum strain. Okay? Because all other planes have the stresses and strain to be in between. I feel some of you have already answered it. So my dear, if you see this question, my dear, how to solve this, I am telling you that. My dear, if you see this, first of all, you will find out sigma 1, 2 because they are the principal stresses. Xx plus yy by 2 plus minus square root of xx minus yy by 2 ka whole square plus tau xy ka whole square. This will give you the value of sigma 1 and sigma 2. No need to change the unit. Everything is given in the same unit, that is nothing but kg per centimeter square. No need to change the units. Mu is given as 0.28, Abhishek. So after getting sigma 1 and sigma 2, you know epsilon 1 is sigma 1 by E minus mu times sigma 2 by E. Epsilon 2 is sigma 2 by E minus mu times sigma 1 by E. You will get the value of epsilon 1. You will get the value of epsilon 2. After getting epsilon 1, you can write epsilon 1 to be delta d1 by d. You will get epsilon 2 to be delta d2 by d. Now d1 is d plus delta d1. d2 is d plus delta d2. You will find one will be coming out to be positive, this will be coming out to be negative. Okay, so you will get the answers. Solve it, guys. This is wonderful question. Majority of you have solved this because this is a question which is most expected for next 2 years. Anybody? Yes. Sachin, where are you? Kameshwar, Abhimanyu. Yes, very good, Abhishek. Very good, Bhavya. So guys, first of all, you will find out sigma 1 and 2. I am telling you the value because I have solved it for you. You will get sigma 1 as 1284. Sigma 2 as minus 684. And then you will find out epsilon 1 and epsilon 2. So you will be getting epsilon 1 as 7.03 into 10 to the power minus 4. And epsilon 2 will be coming out to be minus 4.97 into 10 to the power minus 4. Using this, you will be getting this as 100.07 and this as 99.96. Very good, guys. Is it clear for all of you? Yes. Fine, guys. We are towards the end of the session. Question number 21 now. Yes, question number 21 now. So guys, just like and share the session. This is the 21st question. Okay, 21 to 23, the data is same. At a point in an elastic material, a direct tensile stress of 60 Newton per mm square. 60 Newton per mm square. and a compressive stress 40 Newton per mm square. The maximum principal stress is limited to. You need to find out tau xy. You know sigma 1 is xx plus yy by 2. Xx minus yy by 2. So guys, find out the tau, the similar question, calculative one. Okay, Bhavya, let me check. Okay, you are saying this to be 100.07 and 99 point. Yes. I feel the same will be coming. 99.95 or 956. Like that you will be getting. Okay, Kenil, Bhavya, you guys have answered 21st. Bhavya is saying 41. Kenil is saying 41. Very good. Okay, 100.007. That you are correct. Okay, 100.007. Let me correct that. Because that PPT will be coming to you. Fine. So the answer for this will be coming out to be, guys, 41.53. So answer is going to be B for the same. बहुत ही बढ़िया. बहुत ही बढ़िया, guys. Wonderful. So when you will be putting the value of sigma 1, this is going to be 75. Xx plus yy is 60 plus minus 40 divided by 2 plus square root of 60 minus of minus 40 by 2 का square plus tau xy का square. You will get tau xy to be 41.53. Wonderful, guys. Next, the data is same. You need to find out the minimum principal stress. Now you already know the tau xy, sigma xx is plus 60. Sigma yy is minus 40. And tau xy you have found out 41.53. You need to find out sigma 2. It is xx plus yy. These are formula putting question. Minus square root of xx minus yy by 2 ka whole square plus tau xy ka whole square. So guys, tomorrow's topic is thin pressure vessels and theory of failures. Okay. And then on Friday we have SFD BMD. On Saturday we have deflection and column. Sunday we have the test where you can come in the top 3 position and you can definitely earn the prizes. Very good. So here the answer will be coming out to be what? Jishnu is saying B. Midun is saying B. What about others? So guys, do like and share the session. Kameshwar is saying B. Okay. Bhavya is already have given the answer. Yes. Pranjal, Midun. Abhishek Sahu is also saying B. Wonderful, dear. The answer is B. This will be coming out to be 55 MPa. One more question of the same data. At a point in an elastic material, a direct tensile stress of 60 Newton. Okay, the same data is there. You need to find out tau max now. Tau max is xx minus yy by 2 ka square plus tau xy ka square. Tell me the answer. Yes, Sunday would be the test of SOM on the app, BYJU'S Exam Prep app. There, my dear, you can win the prizes. For that, you need to be in top 3. A test of SOM, the same type of question which we have seen in the Monsoon crash course would be there. it would be for complete strength of material. 1 hour test would be there. Quiz. The answer for this is once again B. So for all 3 questions, the answer is B. Wonderful, guys. Let us see, guys, question number 24. Ambati, dear, I would say that don't think like that. You are very lucky that you have given the mains exam. Just look at the number who appeared for mains paper. In mechanical only 249. Okay, so just look at that number. Okay. The Mohr circle is shown in the figure. The normal and shear stress on plane CD are respectively. You need to find out this value and this value. Yes. Solve this, guys. It is a very easy question. You can see diameter is given. So radius is going to be diameter by 2. And this is the radius. So if you want to find out sigma, sigma is radius minus r cos 60. Tau is r sin 60. This is the calculation required. You know, all the stresses are measured from origin. So this is the value which you need to find out. So that's why radius minus r cos 60. This is r cos 60. So you need to subtract r cos 60 from the r. Very good, Ravi Gupta, aspirant. Just look at it. After looking at the question, you have answered. Don't worry, Ambati, you will be doing really great. Don't worry. So Abhishek is saying D, Ravi is saying C, Bhavya is saying D. What would be the answer, guys? So radius is going to be 1 by 2 of this. So it is 11,500 divided by 2. Yes. Some are saying C, some are saying D. Okay, let me check the answer in that case. So when you will be solving this, what would be the answer coming? Yes, the answer is coming out to be 4980 MPa. D is correct. D is correct. So you will be getting tau as 4980, sigma as 2875. Yes, that is the answer, guys. Very good, Sachin, Pranjal. Question number 25. Okay, let us make this as last question. So this is the given state of stress. This angle is 45. Consider in a strained material subjected to the state of stress. They are asking about maximum principal stress, maximum shear stress, minor principal stress and normal stress at plane AD. Yes. Wonderful, guys. Solve this. You can see the given loading. Sigma xx is 6 MPa. Sigma yy 0. Tau xy is 4 MPa. Just apply the formula. Sigma yy is 0. Find out, guys, what easier than this? Oh, sorry to know, Ambati. But don't worry, dear. You have qualified ESC pre and I feel that you will also qualify for mains. Abhishek is saying A, Jishnu is saying C. What about others? So you will get sigma 1. You will get sigma 1 as 8 MPa. So if you see sigma 1 as 8 MPa, so this is going to match with this. P with 2. So either A or C or B, means D is not the answer. Then you will find out the minimum stress. Sigma 2 will come out to be 2 MPa. Then you will see, my dear, this is going to match with this. So R with 3. R with 3 or R with 4? Plus 3 or minus 2? It is minus 2 actually. Minus 2. Yes. So when you are getting minus 2, my dear, so R will be matched with the 4, not with the 3. So R with the 3 is there in A, R with the 4 is there here. I feel me and Bhavya have made the same mistake. So answer is C, not A. Pranjal, very good. Midun, very good. Ambati, very good. Jishnu, very good. Kenil, very good. Kameshwar, very good. So guys, you guys are really doing wonderful, and I would like to say that in this slide we have 1, 2 and 3 questions. So these 3 questions are homework for you for today, and all these 3 questions I will be solving tomorrow in the class. I would really feel good if you answer these 3 questions in the comment section. Okay, I will be announcing the name, the student who have given the right answer. Okay, you can answer these 3 questions in the comment section. PDF will be given to you on the Telegram channel for this session. Okay, so this is one question. This is one more question related to Mohr circle, and one more question is this. So all these questions are going to be shared to you on the Telegram channel. My Telegram channel is Mechanical by Dheeraj Sardana. Abhishek, if you can share, try to share the Telegram channel link so that students can join it. Okay, fine Bhavya. Fine, great. So guys, actually Abhishek have given the answer as A. Okay. So goodbye guys for today. Tomorrow we are meeting for thin pressure vessels and theory of failure. Day after tomorrow we will meet for SFD BMD, and Saturday we will meet for deflection. 3 more days to complete SOM. Then I will also tell you the schedule of the second subject. Okay. So goodbye for today. We are meeting tomorrow once again at the same time, 6 PM. Those who want to prepare for HPCL from YouTube classes, join us at 11 PM today. We are going to have a session. Me and Rakesh sir would be coming live 11 PM today. Goodbye guys.